Hello, our entire video today is going to be focused solely on looking at this unit circle. And this unit circle is going to be the basis of everything that we learn in this chapter from here on out. So let's go ahead and fill out what we know on the unit circle. Let's start with the degrees because that's what we're most familiar with. We know that we start at 0 degrees, and we know 90 degrees, and 180 degrees, 270 degrees, and all the way around gives us 360. And then we just broke it down a little bit further. We know that if we go halfway, that's 45 degrees. Halfway between 90 and 180 is 135. Halfway between 180 and 270 is 225. And halfway between 270 and 360 is 315. Remember, that's our 45 from 0, 45, 90, adding 45 each time there. And then we also learned about the 30, 60, 90. So here's our 30s. We're increasing by 30 each time. 60, 90, 120, 150, 180, 210, 240, 270 is already there, 300, 330, and 360 degrees. Notice how these are kind of jumbled in the middle. This is halfway. The 30 and the 60, those 30-degree increments, are more towards the center than they are on the outside. Location is very important. And then we spent the whole time doing our conversions. So these were our degrees. Next, we're going to label our radians. First, 0, 0. Our 90, well, we know that from 0 halfway around our circle, if the whole thing is 2 pi, it's just going to be 1 pi. Halfway between 0 and 1 is half. So we know each of these increments are going to be a half, so this is 1.5, which is 3 pi over 2. We can break that down even further. Halfway between 0 and 1/2 is 1/4. So when I'm filling in the 45, that pattern, I'm adding 1/4 each time. So then 1/2 plus 1/4 is 3/4, plus 1/4 is a whole. This is going to be 1 and 1/4, which is 5 pi over 4. Add 1/4, we get 6 over 4, which reduces down to 3/2. Add another 1/4, and we have 7 pi over 4. And we add one more 1/4, and we get 2 pi. Now we still have the 30, 60, 90 angles to fill out. We are dividing that into thirds, so we are increasing by 1/6. 1/6 plus 1/6 is 2/6, which reduces down to 1/3. 1/3 plus 1/6 will give us 3/6, which is 1/2. 1/2 plus 1/3 is 2/3. Plus 1/3 is going, or sorry, not plus 1/3, 1/6. We're increasing by 1/6 each time. Take back what I just said. So 2/3 plus 1/6, which would be 5 pi over 6, plus 1/6, which would be 6 over 6, which is 1, plus 1/6, 1 and 1/6 is really 7/6, plus 1 more 1/6 gives us 8 over 6, which reduces down to 4/3, plus 1/6 gives us 3/2, plus 1/6. Remember, all we're doing is increasing by 1/6 each time for these. So that gives us 11 pi over 6. So what we've done is we filled in our degrees and we filled in our radians. Now we're going to take that one step further and we're going to look back to our trig functions. Alright, hopefully you remember about our trig functions that we plotted the other day. We plotted a point at x comma y. And that is going to be your cosine of theta, comma, your sine of theta. And we did our whole big triangle to show where that came from. And we talked about the fact that sine of theta is your y over your r. And as we talked about, in the unit circle, your radius is 1. So really, sine of theta is equal to y. Your cosine of theta was x over r, and again that's x over 1, and so your cosine of theta is just going to be x. Your tangent of theta is sine of theta over cosine of theta, which gives us y over x. So what we're going to do is we're going to try to find all of these points on our graph. What are the x, the y, the sine, the cosine? To do that, we're going to start by making those triangles that we were talking about in reference to the trig function. So I plotted this point. We drop our altitude. We always come from the center. This is our theta. This is our 90-degree angle. Now this is going to be a 30-degree angle. Because if you remember, your central angle is the same measure as the arc. So from 0 to 30, if this is 30-degree arc, this is a 30-degree angle. So I've created a 30, 60, 90 triangle. And we said that in a unit circle, your radius is 1. So my hypotenuse is 1. Well, the hypotenuse is representing your 2s and your special rights. Across from 30 is your s, so half of 1 is 1/2. And this is s root 3, so that's 1/2 square root 3, which we know we can just write that as root 3 over 2. So when I want to write the coordinates of this point, remember it's your x comma your y. So the distance we traveled horizontally was root 3 over 2. The distance we traveled vertically was 1/2. So the coordinates of that point is root 3 over 2 comma 1/2. Where root 3 over 2 is the cosine because that is your change in x, 1/2 is the sine because that is your change in y. We can go ahead and do that with the next triangle as well. We drop down that point, we connect. This is going to be a 90-degree angle. This is your radius, so this is going to be 1. Now with the 45, 45, 90 triangle, it's s, s, s root 2. So this is representing our s root 2. So if s root 2 is equal to 1, we divide by root 2, we rationalize. So we get that each of our pieces, because we know isosceles, because both of our legs are congruent, is going to be root 2 over 2. And that is going to be for your x and for your y. When we look at our next one, we have a 60-degree, which means that theta in the center is going to be 60. This is going to be your 30. Your radius is still 1, but this time your half of your hypotenuse, because this is 2s and this is 1s, the 1/2 is going to be located here, and the root 3 over 2 is there. So the change in x is 1/2. Your change in y is root 3 over 2. So just remember that when you are finding these coordinates, the first number is representing the cosine. It's representing the distance that you are moving horizontally. The second number is your y, or your sine of theta, and that's the distance moving vertically. So if I look at this point, I'm moving more horizontally than I am vertically. So the bigger number is going to go first, the smaller one's going to go second. This is halfway, so it's same distance left or right as it is up. So those two numbers are going to be exactly the same. And the only difference here is that these are going to switch. When I look at my 90-degree angle, coming from the center, I haven't moved left or right. So my horizontal change is 0. So my cosine or my x is 0. I've moved all the way to the outside of my circle, so I've gone the entire radius of 1. Now you don't have to do these triangles for all of them. You should memorize your quadrant 1 of your unit circle, and then all you have to do is transport that information to the other angles. So if I look at this one right here, let's use black. That's going to correspond to this angle. Now this point and this point are very similar. What they share is the fact that they both are moved up the same distance. Since they both are moved up the same distance, they're going to have the same y value of 1/2. Then I look at the distance traveled right. It's the same distance traveled right and left. The only difference is this one is to the right and this one is to the left. So when I move to the right, it's a positive root 3 over 2. When I move to the left, it's a negative root 3 over 2. The same is going to be true for our next one. These two correspond, and they both again are moving the same distance up, so this is still a y value of root 2 over 2. Same distance right as it is left, the only difference is right and left, so while this is positive, this one is going to be a negative root 2 over 2. And as you can guess, these two are going to correspond. Again, they're the same distance up, which means the y value is going to be the same. That's root 3 over 2. This one went to the right, this one went to the left. They're going the same distance, but since this one is going to the left, it's a negative 1/2, comma, root 3 over 2. We can do that same idea when we move to the other side. I can say that these two correspond. These two are the same distance left. If they're the same distance left, that means that the x-coordinates are the same. Negative root 3 over 2. And this one moves up, this one moves down, but it's the same distance up, same distance down. But since this one's moving up, it's a positive 1/2. Since this one is moving down, it's a negative 1/2. So you just want to look at the relationships between all of your points. Are the x's the same or the y's the same? Are they the same distance? One's positive, one's negative. What I want you to do is go ahead, you have a little bit less than half the circle left. Oh, actually, let's do one more together. Let's look at this one right here. We are going all the way over here. We have our x's first. We went left a negative 1, and we didn't move up or down any, so that's a negative 1, 0. Now I want you to go ahead and complete those last remaining pieces of your unit circle, filling in your coordinates, which are representing your cosine and your sine. Go ahead and press pause. Okay, let's see how you did. Go ahead and take a minute, press pause if necessary, and check your answers. When you are looking through, again, sometimes you have to just take a step back and think about it instead of trying to memorize. When I look at this, when I go from the center, I'm going left, which means my x is going to be negative, and I'm moving down, which means my y is going to be negative. So think about the direction in which you're moving and which one should be positive, which one should be negative. Which one's bigger, which one's smaller, or are they both the same? Now, unfortunately, we are not done just yet. We did our sine and we did our cosine, because if you remember, and hopefully you do, the first one is cosine of theta. Your second number is your sine of theta. But we have three main trig functions that we're going to look at when we're looking at the unit circle. That's sine, cosine, and of course we can't forget about our tangent. And tangent of theta is sine of theta over cosine of theta. So when I look at this, I want sine of theta over cosine of theta. The 2's cancel out, but then I have to rationalize. So my tangent of theta is going to be root 3 over 3. I do my sine over cosine. Those are exactly the same, so that's just going to be a tangent of 1. Here we've got root 3 over 2 over 1/2. Your 2's cancel. Root 3 over 1 is just going to be root 3. Again, these are your tangent values. Our y over our x, the tangent of 90 degrees is going to be undefined. Our y over, you know what? What did we talk about? Don't do all that long work. Remember, we have patterns. If this tangent is root 3, these are the same numbers that we're dividing. Y on top, x on the bottom. The only difference is this one has one negative. So instead of being a positive root 3, it's going to be a negative root 3. Instead of being a positive 1, we have a positive and a negative. This is going to have a negative 1 tangent. Here, this one's going to correspond to our first one, root 3 over 3. we have 1/2 divided by a negative, so that's going to be a negative root 3 over 3. Our y over our x is going to give us a tangent of 0. That's going to be the same over here. 0 over positive 1 is going to give us a tangent of 0. Going down to the bottom, remember this one is corresponding to this piece right here. Now, unlike this one, we have a negative divided by a negative. Remember, the x's are the same, the y's, the only difference is one's positive, one's negative. So they're dividing in that same way. So if I did my y over my x, doing it the long way, the 2's cancel, I have to rationalize, and I end up with a positive root 3 over 3. This one had 2 negatives, so when I divide them, they become positive. So this one is going to be a positive 1. A negative divided by a negative, this is going to give me a positive root 3. A negative 1 over 0 is still going to be undefined, just like the 90-degree angle one. These two correspond. This one has, whoops, man, hopefully someone caught my mistake before. This is a negative root 3. This is the y. We went down, so that should be a negative root 3 over 2. So if you corrected your mistake before because you thought I was right, go ahead and fix it because I was really wrong. I made a little mistake there, forgot my negative sign. So we have 1 positive, 1 negative, so this is going to be a negative root 3. 1 positive, 1 negative, that's a negative 1. And 1 positive, 1 negative, so it's going to be a negative root 3 over 3. The unit circle is going to have a ton of patterns that go throughout. So make sure that you have this unit circle down, and you don't want to try to memorize it. The goal is to understand it. And if you understand it, it's going to come really, really easy to you. So we're going to try one example. And that one example is going to be, I want to know what the sine of 300 degrees is. So if I want to find the sine of 300 degrees, I go to my unit circle, I find 300 degrees. If I'm looking for the sine, that means I'm looking for the y coordinate. So the sine of 300 degrees is a negative root 3 over 2. I can ask you any sine, cosine, tangent, secant, cosecant, cotangent of any of these angles or radians on this unit circle. You go to that given angle. If it's cosine, you look at the x coordinate. If it's sine, you look at the y coordinate. If it's secant, you take the reciprocal of the cosine. If it's cosecant, you take the reciprocal of sine. You have your tangent listed, so for the cotangent, just take your reciprocal. Go ahead and when you look at the back side, make sure that you bring this piece of paper in class tomorrow because we're going to go ahead and complete the back side together in class. But for now, we are done.